Let's go to goal number 5.
We do experiments with humans navigating in an industrial-like environment. We have a very nice motion capture system installed at the roof, which is capturing the motions of the humans, and we have various scenarios where we investigate how they move if we change certain things about the environment. It is very useful for applications where we want to know how people are moving in certain settings. For instance, in industrial environments, in-house, for example in a factory, you have a service robot that has to navigate through shelves, and it encounters a human, and it has to know where the human is going in order to plan an efficient and safe path. So this is a camera of the motion capture system that we use. With the motion capture system, we have helmets that we put on, and then we collect the trajectory. And what we do is we train algorithms, like for example machine learning algorithms, to learn the patterns of the movements, and based on those patterns of the movements to better predict what people might do in the future. We also measure other things, like for example eye gaze patterns. Here we see already very interesting results as well. So this robot is supposed to produce readable social cues for humans. So to say, I will go there in an understandable manner, that the human knows where is the robot to go next.
Let's go to goal number 4.
For me, the most interesting part of the experiment is the motion of the people under the circumstances. For example, we have people carrying boxes from one point to another. How is this different from the people just walking from that point to the other? And also the interaction with a robot.
Let's go to goal number 2.
How are people moving when they interact with the robot? The robot tells you, please help me, let's go to goal 2. And then you go with the robot. How does your trajectory change? How do you feel about the trajectory change? Right now, it's a really challenging aspect to predict long-term human motion. In long-term here we mean several seconds, like more than 10 seconds. And we really hope that in the future, also with our contribution, this is going to change so that we can predict more and longer trajectories, like say up to a horizon of 50 seconds or even 1 minute maybe, and still be as accurate as in a short-term horizon under 10 seconds. To be used in warehouses, for social robotics, for autonomous driving, everywhere you want to predict how a person is moving.